Hi and welcome to my channel. My name is Magnus, and in today's video we're going to talk about firewall scaling. So this is the topology that we did have in our last video. More or less we have two firewall clusters. But how do we decide what sort of boxes should we put there? And depending on what sort of design or what sort of boxes were put there, how can we scale from that? So Checkpoint, as all other vendors, they offer a bunch of different appliances. So they offer everything from like small business or home offices to large like data scale appliances. And Checkpoint also offers like for industry like rugged devices that can take extreme heat or extreme cold, so you can put them in bad environments or industry environments. And they also offered like software based, and we will cover some of this, not all. And of course you have like different scales, so you can see like, yeah, this is ranging from a few hundred megs to a few gigabit. But 30 gigabit, maybe that's not enough within a data center. So of course there are new functions that comes out, and Checkpoint, for example, they have previously released like acceleration cards, and they have done something similar now with the quantum light speed. So more or less you can have dedicated interfaces in this. So together with NVIDIA, Checkpoint has made a card where you can run like wire speed, and this is 100 gigs interfaces. Will this cover all type of traffic? No. But it will cover some sort of traffic. For example, if you want to run like backups, maybe you only want like firewall in there. You don't want to add additional, URL filtering or application control or IPS or whatever. So there are good things when it comes to being able to accelerate specific type of traffic. So you don't need to bypass it and send it in a router, so you don't get a log for it, but you don't want to buy a firewall that manages 100 gigs because you should just send backup traffic in it. So and just to have said that as well, most of the traffic that Checkpoint process will go up to the CPU. So this has been a drawback previously, when like the CPUs were slow, and a lot of other vendors, they did go with the different ASICs to process specific traffic. But when you want more advanced things, more or less you need to run it through some sort of CPU. And I believe because of this software architecture, Checkpoint has been able to, first of all, come into the public cloud very easy because it's software based, so you don't need to like restructure all the code. I'm not a coder, but it must be easier if you used to relying on CPU and don't need to change from, yeah, we're doing everything in ASIC and now we need to do that in public cloud. Oh my god, how should we do it? So I think this is a good approach. I don't know what I was talking about, so let's move on. When it comes to appliances, there's always like, okay, we are going to buy an appliance, no matter what size it is. Then you need to decide like, what is the write-off period of this? How long can we keep the appliance? So in normal, you buy like, let's say network gear or computer gear on 5 years. That's pretty standard. So, or 3 years, 3 or 5 years, that's like normal. So when it comes to like physical boxes, then you want to make sure like, okay, how long do we have support? How long can we keep this box? Is it okay to keep this 5 years? And now I'm only talking about the support. I'm not talking about like the performance or anything like that, only support. Because when you buy a product, you want to make sure that this is supported, that this get new firmwares, this get new updates, so you're not needing to replace the box after 1 year. So when it comes to like normal technical support, Checkpoint offers, if you have a service contract, of course, that these are supported 5 years after the successor product is available. So if you can buy the product, and I will change to this one. So if you can buy the product and the new box that is replacing the old box hasn't been released yet, the 5 years has not even started to count yet. So let's say that the new box is released, like version 2. When that box is released and is available for purchase, then these years start to count. Does Checkpoint offer like the full like new software versions, etc. on all the appliances? No. So we see here that we have full tax support 5 years after the product's availability date. But we only have 1 year for new software versions. So security hotfixes, maintenance releases and so on, they will still be available. But when it comes to like major releases, it's not sure that they will be supported. They guarantee that it's supported 1 year after the successor. So, and this has to do with like memory, CPUs or whatever, like performance of the boxes. Can you actually run the new box? Do you have enough hardware? Do you have enough like disk space? But this is important to know, like, yeah, we can have the boxes minimum 5 years, so that's great. To be able to like utilize the hardware in a better way, Checkpoint offers something called Maestro. So Maestro is a way to cluster appliances. More or less you have an orchestrator. Preferably you use 2, so you have some redundancy. Then you can add up to 52 appliances into this cluster. And they will load balance between the different appliances. And they will act as one. Or they can act as one. So I said before, like, yeah, you can have 30 gigs of traffic in the large appliance. Well, you can have 30 gigs of traffic times 52. So then we start to talk about a real large environment of a huge amount of traffic. But it's limited to appliances. So if you would go for this kind of setup, you need to check the limitations. Like, okay, can you mix appliance types? Depends on the version, depends on the appliances. So before you jump into something like a Maestro or any sort of technology, make sure to check like the limitations. Are you fine with the limitations? Or is this a deal breaker? I mean, it really has to do with how you want the traffic to flow. If you have a lot of departments, you want to split up a lot of things, like you have test, stage, development, guest traffic, internal traffic or whatever, does all of this need to pass the same firewall? Do you need the performance in the same policy, in the same firewall? Or you can split up this in multiple clusters. Maybe it's worth to have multiple clusters because it's easier and you don't need the specific performance for one type of traffic flow. So this is something that you should consider when you design your network, when you purchase your things. Because if you have multiple different clusters, you can actually decide like, yeah, this cluster should have this type of performance, they should have this type of functions, they should be managed this way, this type of cluster should be managed a different way, they should have this performance. It gives flexibility, not only for like design, technical part, but it also gives flexibility when it comes to like purchasing. Okay, how do you divide cost? Okay, this cluster is now owned by this department. So it depends on your company structure as well. So this is the topology that we did look on before, but I've changed the icon so it's now a cluster. You should always build firewalls with clusters because you want to be able to maintain them. you want to be able to like not only to maintain for upgrades and all of that. What if something fails? It's very unlikely that 2 boxes fails at one time, but it's possible that one box fails due to a power supply, or let's say the power turns off in one of the racks or one of the PDUs, etc. So there's always good to have 2. So there should be really specific reasons why you don't want to build with a redundancy. And one of these reasons could be like a remote office where it says 10 people. Maybe you don't need to have redundancy on your firewall there. But then you need to like consider, okay, what happens if this specific single gateways go down? How long could it take before something doesn't really work? So let's say like, yeah, this is just a remote office where it says 10 people. In worst case, they can work from home for 3-4 days while you ship the new box. And if that's not good enough, maybe you should have a spare part available in your own office. And if that's not good enough still, then you should have redundancy there. So if you cannot be without the specific location for, let's say, 4 hours, redundancy. 8 hours, okay, is it possible to change it if you have a spare part? Yeah, maybe. What if it happens on Christmas, 2 in the morning? Not likely. So you need to decide like what sort of SLA or what sort of return to service do you need? And that's how you decide like if you need redundancy, if you need clusters, if you need multiple links, etc. So when we build clusters with Checkpoint, we use something called Cluster Excel. So when it comes to Cluster Excel, you have one active and one standby node. So within your cluster that you have bought, let's say they cost $10,000 each. Then you have purchased equipment for $20,000, but you can only utilize performance from the $10,000 because you can only utilize one box at a time. When it comes to Maestro, for example, you can utilize multiple boxes at the same time. So your investment, you don't need to calculate with so much redundancy because you can lose like boxes. You can build a cluster with 3, 4, 50 members or whatever. So the utilization power or the utilization efficiency or whatever you call it, it's higher. But there are ways around this as well. But you need to consider like, okay, we buy a cluster, we have 2 members, but we can only send traffic in 1. So more or less half of your investment is sitting and blowing warm air. This is the cost of redundancy. But there is also like VSX with VSLS. This is my baby. So if we have our cluster with an active standby, when it comes to VSX, we can add multiple boxes. So even if we only have 2, we can still utilize both of the boxes 100% if we want. But we can build larger clusters. So we can more or less make the redundancy cost cheaper. Because if you have 2 boxes and you use 100% load of both the boxes, what happens if one box go down? Well, then you get 50% of the performance. Is that enough? Maybe. So what is VSX and VSLS? VSX is the possibility to create virtualized firewalls. And VSLS is the possibility to distribute them along multiple cluster members. So in this example, we have 3 different virtualized firewalls. So we have VS1. So VS1 is active on member number 1 and standby on member number 2 and backup on member number 3. So what does this mean? The active firewall can only be on one node at a time. So the limitation for VSX, there are more limitations, but this is one of the limitations. The virtualized firewall can maximum utilize the performance of one box. When it comes to Maestro, one firewall can utilize the performance of multiple boxes. So it's a different way to scale. And this means that you need to design in a different way. But in this scenario, you still have like 3 members. If one of them is lost, you lose 33% of the performance available. Maybe that's good enough. But you can have 8, 10. I think the maximum is 13 members. Could be 12. You need to check that because it can depend on different versions and stuff change. I wouldn't build so large clusters. I would split them up in multiple clusters if so, because it's easier when it comes to like upgrades and so on. So I think the sweet spot is 3 or 4 members when it comes to VSX. After that, you should split it up in multiple clusters, not because of performance and so on, because of how you maintain the specific cluster, how you do the upgrade procedure and so on. It gets a lot more complicated with more boxes. So if we design with VSX, we have 4 boxes in this case, and we split them up in 3 different virtualized firewalls. So like we have the green, the blue, and the orange or yellow here. If they want to communicate with each other, we need to build something called a vSwitch. And we can add, so the green firewall is active on one node, the blue is on one node, the yellow is one node, and then we have one standby. Meaning we can lose one of the boxes without losing any sort of performance at all. But then we need 4 boxes and we need to have made 3 firewalls. You can add 10 firewalls, 10 virtualized firewalls, and you can divide them up like, yeah, I want 3 of them to run on the blue one, 2 of them to run on the yellow one, and whatever. So you can mix and match. So do you see how you scale this? You scale this, what is it called, horizontally. So you need multiple different firewalls with different functions, and each of these different virtualized firewalls, they have their own routing table, they have their own security policy. So they are really like a dedicated box. You can even dedicate specific interfaces for a specific box. It's not so common that you use that or do that. Mostly you do a few bond interface and then you send all the traffic on trunks. So there are drawbacks of this. As I said before, you need to be aware of limitations. If you're not aware of limitations, you may come into a lot of troubles. Because you shouldn't assume things. You should read up on what is the limitations, and if the vendor doesn't provide you with limitations, they are not a very good vendor. So what is one of the design consideration when it comes to this? Okay, if we would have one firewall, and this is only different VLANs, then we process the traffic once. But if we have multiple virtualized firewalls within the same hardware cluster, the green traffic, if we're going to send traffic from the green boxes to the blue boxes here, we will pass this firewall, the green firewall, then the traffic will be passing through this virtual switch internally within the boxes, or like between a NIC on the boxes. And then the traffic will be processed again through the blue one. So if the green and blue is on the same physical hardware, the same physical box, they will use performance on the same physical box. So the traffic will be processed multiple times. And they can be processed multiple times with different type of blades. Like, you don't need to have like IPS enabled on the green one, but you could have it on the blue one. So you can mix and match. But you need to keep this in mind when you're designing your network, your environment. So this can be complicated. This is something that you need to think about. It's good if you have some experience of it. I think I have a full series about VSX and some design consideration, how to manage it and so on. You can check that out on the page as well. So if we now go back to the topology again. So with VSX, it's possible to run like all of these boxes, these virtualized firewalls, within one VSX cluster. But it's like this logically. So you can separate and you can build different ways. And then if you remember our first one, when it comes to like DDoS and so on, okay, what happens if you get the DDoS from internet to the external firewall here? Well, you actually assign an amount of, they call VS instances. It's more or less CPU performance. And you also assigned a number of connection that correlates to memory. So it's actually possible to like send, let's say 1 gig of traffic to this specific one, and it goes 100%, and these are not affected at all, and the boxes still have a lot of performance left. But DDoS doesn't need to be volumetric. It can be like with connections. It can be, even if it's volumetric, maybe you fill the interfaces. So then it has to do with like, okay, so it's all the VLANs on the same interface. What happens if I fill the interface on this one? Do it affect everything? So even if you build with VSX, maybe you should separate like external traffic from internal ones. You have different NICs for it, so you don't affect like traffic between different server VLANs for internal one, and only affect like internet to inbound. So there are a lot of design considerations, but the idea of this video is you understand you have the possibility to scale. So let's say like, yeah, okay, we need to add even more performance. Then you can add one more virtualized here and utilize the 4th member node. So use 100% of the hardware. If you're fine with like, okay, if we do any maintenance, if we do any problem whatsoever, we get less performance. But you understand the scalability possibilities when it comes to this one. Also, if you need like, yeah, we need a different firewall cluster for this, then you have the possibility to spin up one new virtualized firewall for like guest access or guest network. That should be completely separate from everything else and should not be connected to the same VRF, same VLANs or whatever. It gives a lot of flexibility and scalability, and you don't need to wait for delivery and so on. As I said previously in the video, Checkpoint doesn't only offer like appliances. You can run this on software. So now we're talking about my baby. It's like open servers with Checkpoint software. That's nice. Running VSX and VSLS. And you can have up to 72 cores per box. So imagine our cluster. Let's say we have 4 nodes. We can have a cluster with 4 nodes and each of them have 72 cores. So even if you can only maximum utilize one physical box for one virtualized firewall, 72 cores is a lot of damn traffic. So, and there are some really big benefits of running like software. So the software licenses are perpetual, meaning you own them. You don't rent them. So they are CapEx investment. Then you pay OpEx, meaning support and blades and so on. Subscription licenses. But they're also transferable. So if you have an HP box or Dell box or whatever, server that is supported by Checkpoint, and you have, let's say, 16 cores on it. After 5 years or 3 years or whatever time frame you want, you replace this box, this HP or Dell or whatever server, with a new one. And then you transfer the license to the new hardware. So, of course, the hardware need to be compatible, and Checkpoint has something called a hardware compatibility list. Hardware compatibility list. I mean, it stands right in front of me, so I should be able to see it. But it more or less say like, yeah, these boxes are supported. You're allowed to use this specific NICs. So there are different tabs for different NICs and different servers and what sort of version they are supported from. But what I mean with like, yeah, you can just buy a new box. As I said before, most of Checkpoint traffic is managed by the CPU. So what happens during 5 years with Intel? They release new CPUs. They make them a lot better. They are a lot better in processing traffic. So even if they are more or less the same gigahertz, they are still faster because of, I don't know, architecture or whatever. So you can more or less get a brand new cluster for a lot less money by just changing the open server. And yes, open server licenses are not super cheap. It depends on your contract and so on. And of course, the vendors will try to sell you appliances. I think this is the wrong approach, because if you want a long partnership, software is quite a nice, let's say, lock-in. There are benefits if you calculate on a longer time span than 3 or 5 years. Maybe if you calculate on 7 years or 8 years with one hardware replacement. So then you can also justify the cost a bit easier. But then you need to, let's say, you need to set the path, and you need to follow this path for a long period of time. But for large environment, this can be really efficient. So you can actually also rent, like when it comes to CloudGuard. CloudGuard is what you can run in public and private cloud. So this is for like Azure, AWS, or even like VMware NSX and so on. Then you can run a virtualized VM in your environment that you put Checkpoint software on, and then you have a firewall. And this one you can actually auto scale. So if you run it in public cloud, you can auto scale this. So you can start with 2 CPUs and go up to 8 CPUs or whatever you need. Talk about scalability and flexibility. These licenses from start, a long time ago, they were perpetual. They are now only subscription based. So you pay for usage. And if I'm not mistaken, it's per year. I think there are pay-as-you-go licenses also available in the public cloud, but if you want to run it in private cloud, it's per year. Per year, per core. And you can like combine them, split them up. So it's a great way to get a cluster up and running quickly. You just need to calculate that it will use the CPU performance given to it. And they have some reference like how much traffic can you push through it. And as they are subscription based, they also come with NGTP. So they have like anti-bot, antivirus, a bunch of different things available on them from start. And just to be like clear for it, I have some certain type of traffic and some certain type of environments where I run appliances. I have different type of environments where I run my open service with VSX and VSLS. I have different type of environments where I run this CloudGuard, the virtualized firewalls. So they have different user cases, and all of them can be combined, and all of them can be managed by the same management server. So this is like the core functionality that I really love about Checkpoint. The possibility to scale it how you want it, to build it more or less how you want it. The only drawback of this is too many options and too little like, you should build like this. Therefore you need some experience. So I think that's it for this video. It's super long, I guess. So thank you for watching, and I hope to see you in the next one. Take care.